Hello, my name is Orga Felix Cosmin, and I'm here to present my thesis entitled An Interactive 3D Web-Based Platform for Urban Air Quality Visualization and Spatial Evaluation in Cluj-Napoca. When the user first accesses the page, he will be prompted with this landing page in order to act as a buffer, so it does not confuse the user when it first lands on the page. As soon as the user clicks the Explore Now call to action button, he will be prompted into the view of the 3D visualization of the city of Cluj-Napoca. This is a downscaled version of the city, providing a better performance with a lower level of detail, on which 3D spherical metaphors are displayed according to the air quality level of each monitoring station that exists in real life in the specific zone. Whenever the user decides to click on the sphere, he will be displayed with a sidebar containing information about the specific sensor that he just interacted with. For example, this one has a 65 air quality index. It also presents the medical recommendation for the air, for the exposure to air in the specific area. In this case, the air quality is moderate and it may be a risk for very sensitive groups, as well as the address. These sensors are provided with the help of the air quality, world air quality interrogation of the API, and are also color coded according to the US 2016 EPA standard. As you can see, the air quality index here is 156, and some members of the general public may experience some health effects. These spheres are again represented as a 3D metaphor and are meant to encapsulate real-life sensors. Besides the navigation of the map, the user is also able to input coordinates from the Google Maps or any other software that provides geographical coordinates. He can paste them and input the latitude and longitude of the desired input. For this time we chose the middle of the stadium, sorry. And whenever the user clicks submit, it is prompted with the view of the stadium, as well as a 3D object that signals where the interrogation and where the original coordinates of the users were chosen. And then on the left side we can see that it is also displays the computed distances to the city center, the train station, and the closest public transport station, which is Cluj Arena. This is a way for the user to evaluate specific areas according to their needs. As for the code, it is an Angular based app that also encapsulates 3JS as a way for interacting with the 3D models. The app is split into different components. For example, the main page component is responsible for the view of the main app, the city visualization, and it incorporates the 3JS 3D scene, which is encapsulated in an HTML canvas. As you can see on the main page HTML, this sidebar is used as a prime ng component, which conditionally renders using the ngIf procedure to conditionally renders the information about the air quality monitors. The scene is also created only after all the instances of the air quality monitors are retrieved from the World Air Quality Service. This service provides us with two very important methods, which are called in the get all stations method. The World Air Quality Service calls the get all stations of city method. This retrieves an HTTP URL of the available sensors, and then uh, prompts them down the pipe and merges them with the help of a fork join so that it can synchronize it with the call of another API, which transmits the ID from this said URL to the get station data method. This method uh, retrieves the data of the real world sensor, which is then prompted one by one, like in a pipeline, into the filter. This filter takes every result, checks if the message is an error or not, and if not, it then uses the lat long calculator service in order to translate the geographical coordinates into Cartesian plane coordinates. And then it creates a new sensor which has the latitude and longitude in the real world geographical coordinates, the x and z Cartesian coordinates, and as well the air quality level and the name. Then it is loaded into the map via the load sensor method. This method just loads up on a separate layer every monitor that was provided in the method presented before, and then it creates a sphere with the with respect to the USA 2016 standard. We can then move on to the other important part, which is the life quality calculator, which then uses the ng models in order to efficiently display data from the life quality calculator. It uses a Haversine formula in order to take into account the spherical attributes of the Earth, as well as an API to find the distance and all of the specific public transport stations. This has been the short presentation of my app. Thank you for your attention.